Okay, so let's continue with our Kafka Python tutorial series. So in this video, we will cover the concept of the consumer group, and we will see everything in the practical using the hands-on using our Python code. Okay, so before jumping on that, we need to know what is consumer group. So if you just read the term consumer group, so it is a group of consumer, but what exactly it is? Is it like the different consumer, or it is a same code running twice? What exactly it is? So we are looking into that, right? And we will see what are the different scenarios, right? Okay, so let's before jumping into the consumer group definition, let's see that very basic scenario. So in the basic scenario, what we have covered till now. So we have our one broker running, right? So let me spin up my Kafka cluster as well. Docker compose up. So it is because we are using the Red Panda, and for the UI we are using the Red Panda console. So both are going to spin up at the backend. So till now what we are doing is we are making our Kafka cluster up, which is broker. Then we have our producer code, and then we have our producer consumer code, and we are creating one topic, and in within the one topic we are creating only one partition. So producer is producing some messages, and it is going only in the one partition. So what is partition? Partition is basically each topic can be divided into one or more partitions. So topic has, you can say, folder has subfolders, a kind of things. So a topic kind have multiple partitions, like partition 0, partition 1, partition 2. So by default is partition 0. So it could be one or more partition. So till now we have only one partition. Producer is producing the message, and consumer is consuming the message. Though we have only one consumer, but still we are calling it as a consumer group. So consumer group doesn't mean that there should be more than one consumer. No, consumer group, even we can say that if there is a one consumer, it means that group only contain one consumer. So if you, let me see if my console is up. So my Kafka cluster is up, right? So my Kafka cluster is up, and there is no topic, there is no schema registry. So this is our default scenario. So our broker is up. So only our broker is up till now. And if you see our current code, so let me go to my current code. So let me quickly open that. Okay. So this is my current code, and if you see here, we are creating the topic. So we are creating the topic, and here we are not passing any kind of a partition. So by default only one partition will be created, right? So this is our like producer code. And if you see the consumer code, in the consumer code, though we have only one consumer, but still we are passing the group ID, right? Still we are passing the group ID. So why we are passing the group ID when we have the consumer? So by default consumer, either it's one consumer, either it's two, either three, that consumer part of the some group, and that group should have some ID. All right. So if multiple consumer have same ID, then we can call as a consumer group. Otherwise, it could be different consumer of different applications. All right. So maybe I have one microservices, and I am the user. You are also the user. So you are the different consumer. I am the different consumer. You have the different ID. I have the different ID. So it doesn't mean we both are of the same group. No. But if we say consumer group, either I am the only one can be part of the same group, or if like I have, like, there is a replica, there is a copy of my like my consumer, right? But it has the same group ID, so it will come into that consumer group. We will cover see in the practical, then you will like better understand. So till now we have only this. So if you just run this code, so let me quickly run this code. Python avro producer.py. So you could see topic has been created and schema has been registered successfully. And if you refresh it, if you click on the topics, so by default we are creating only one topic. So by default we are only creating one topic, right? So if there is a one topic, so only, sorry, by default only one partition. So one topic, one partition. And if you, and let me spin up the consumer code as well, and let's insert summary code. Insert, let's add summary code. Right. Let's add in some record. Okay. Okay. So age is basically integer, and I am again and again passing the string. So Python neighbor producer, insert some user ID, name, integer, this, and then insert, and user ID should be integer, name, age. Oh, okay. It's fine. Like already we have inserted a couple of records. Already we have inserted a couple of record. So let me go to the message. So you could see all the messages are coming to the same partition, zero partition, because it doesn't have any more partition. And the consumer is consuming, this consumer is consuming all the record. So it has three messages. It has like consume all the three messages. So let me remove this logging statement byte message, because we don't need to unnecessary print the byte message. I can remove this. Yeah. So so we have only one producer. Producer is anyhow like we have one, but we have one topic, and in the one topic we have only one partition. So if there is a one partition, that consumer is going to consume only from this partition, which we already see. So that is the one scenario, which is the basic scenario. But is the other scenario? The other scenarios, if we have two partition and only one consumer, then what is going to be happen? So let's create two partitions. So how to create a two partition? First thing is that, because till now we are creating only whatever the topic we created. So whatever the topic we created, so if you click on the topic, we have only one partition. Number of partitions are one. Now we have to check this scenario. If we have two partition and one consumer, what is going to be happen? Can consumer going to consume from both the topics or not? Right. So we are going to see that. Till now we have consumer group concept did not started, but before that we are like seeing different consumer group uh, going to be started. Actually consumer group, we can call it as a consumer group itself, because that consumer is part of a consumer group. But whatever we are going to learn in this video is that is the scenario 3. That is when one consumer has two consume one consumer group has two consumer. But before that we are going to cover this scenario when uh, one topic has two partitions. So how we are going to create the two partition? Because to do this scenario, one topic should have two partitions. So let's create it one two partitions. So how we can create it two partitions? So let me open my official documentation. And using the admin client, we are creating a topic, right? So in the create topic, we are passing the new topics, and new topics has one parameter called number of partitions. So by default, number of partitions are passing as a one. So now we need to pass some argument, right? So let's come here. Let's remove this number. So we are creating a topic. So creating a topic, and we are creating a new topic. A new topic, number of partitions, num partitions. So it has one parameter, num partitions. So we need to pass this, right? And it will take partitions, and partitions we are going to accept. And by default, we can pass one partition. And here by default, we can pass. So now we are going to pass the two partitions. So now when I am going to run my producer code, two partitions should be created, right? So let me quickly stop my console. Docker compose down, uh, hyphen a, Docker compose up. So now my Kafka cluster is up and there is no partition. Let me run my uh, code. So now my topic has been created. Let's refresh it. Now you could see it has two partitions, right? It has two partition. Now it has two partition, and so now our producer is going to create the records on both the partition, but consumer is still running. One second, let me refresh the consumer. So consumer is still running. So consumer is going, we have to check whether the consumer is going to read from both the partition or not. First, we will check whenever we are going to insert the record, is it going to insert the records on both the partition or just only on the one partition? So let's see. So user ID 1, page 1, insert user ID 2, insert user ID 3, user ID 100, insert, okay, insert Python app producer, Python app producer, insert user ID 100, 100. Let's see, we have already published for 3 4 records. Okay, so now you could see it is randomly assigning, like some messages are going to 0 partition, now some messages are going to partition number 1, right? But let's suppose sometimes you have to like control this behavior, like in your end. So if you want to control this behavior, what you can do is within our like wherever we are defining the producer class, where we have defined the producer class, where we are defining the bootstrap server, so we can pass one more parameter, that is a partitioner, and we can give as a value called random. How I go to know this? So let's open the official documentation. So you remember in one of the video we were looking about the producer and the configuration parameter. So if you click on the producer configuration parameter, and if you search the partitioner, right? So you could see partitioner dot class. So which is going to determine which partition to send the record to, which records are produced. So, but the parameters partitioner dot class. All right. In our code, I am using partitioner. Why? So this documentation, anyhow, it's for the Confluent documentation, but it is a common documentation. It is not specific to the Python, or it's not specific to the Java. This is the common documentation, but we are using the Python API. So for the Python API, we have the separate documentation. So we have the Python API. So this is the documentation. And because our Confluent Kafka API is built on top of this library. And if we search here, partitioner, so here we have only like parameter partitioner rather than partitioner dot class. And by default, we have the consistent dot random. We can pass random as well for the random distribution, for consistent as well, CRC332 hash of the key. So by default is it's consistent random, and but we can use random or like any other thing as well, right? But anyhow, and but if you click on the consumer, will consumer able to read all the records? Yes, consumer able to read all the record. Consumer able to read 1, 2, 3, and 100. So if I go to the topic, so 1, 2, 3, and 100. So it means consumer able to read from both the partitions. So this scenario also done. So that is also a kind of a by default scenario. Now, what is going to be happen when we have the two partitions and when we have the two consumer? What is going to be happen? Because if you come here, if you go to the consumer group, under the consumer group, we have like two partitions, right? So we have two partitions, and it has the same member. I think it is the same member. Same member is going to be assigned. All right, and we have two partitions. And now what we are going to do is we are actually going to learn about the concept of the Kafka consumer group. So now we will create two consumer and two partitions. So two partition we already have. So we are not going to stop our producer application. Well, let's stop our producer application and let me start producer.py. Why I started this? Because I like assigned this parameter partitioner as equal to random, right? And yeah, that's fine, that's fine. And let's open the my Avro consumer, right? So now because my Avro consumer is going to take group ID, and it has group ID, my group ID one. So if I start this code twice, so let me start this code as it twice. Let me stop this Python Avro consumer. So I started on this terminal, and let me start on this terminal, Python Avro consumer, and I started on this terminal, right? So now I started this code uh, twice, right? So if you come here, so now you could see it has different consumer group, right? And for this consumer, partition 0 has been assigned, and for this consumer, partition 1 has been assigned. So which means now this consumer is going to read the records only from the partition 0, and this consumer is going to read the records only from the partition 1. This consumer is not going to is not going to read from the partition 1, and this consumer is not going to read from the partition 0. So that is the concept of the consumer group. So what consumer group will do is, so consumer group are consist of one or more consumer sharing the same group ID. Because I have spin up the same, I started the same consumer code twice. You can say like a two Docker instance running or two EC2 instance running or two consumer application running, but they both are sharing the same consumer group ID. Right. So now within my consumer group, so now we are covering the third scenario. We have the two partitions and the two consumer group. So now our going producer is going to randomly going to push the message, sometimes partition 0 and sometimes partition 1. But at the earlier what is going what was happening, we have only one consumer. So if we have only one consumer, this consumer, like, it has to do two tasks. It has to read from the partition 0 as well, it has to read from the partition 1 as well. But if we want to like implement the concept of the parallel consumption, maybe we have the multiple producer, right? Or maybe the producer speed is very high, consumer speed is very low, and producer speed is very high. Or maybe one consumer is going to be down, and we want to speed up the concept of the parallel consumption. So what we can do is we can speed up the two consumer. But when the two consumers going to spin up, one consumer is specifically assigned to one partition, the other consumer is going to assign to the another partition. Which means if producer 1 going to publish 100 records on partition 0, all the 100 record will be consumed by the consumer 0. And if producer is going to publish only two records on partition 1, only two records are going to be consumed by the production 2, producer 2. All right. But consumer first is not going to read this the remaining two record. So the second consumer only has to read the second record. If this consumer is going to be down, let's suppose the second consumer is going to down, then by default this partition is going to be automatically assigned to the first consumer. That is this scenario by default. That is the Kafka internal behavior. But we have to see that. So let me insert a couple of record. So I did 200, enter first name, last name, 200, insert 201, 201, insert 202, insert 203, insert 204. So let's see whether all the messages are publishing. Okay. So you could see 201 and 203 assigned to partition 0, and 200, 202, and 204 assigned to partition 1. But let's see at the consumer end. So if you see consumer 1 only read 201 and 203. So these two messages should be from the same partition. So let's see whether 201 and 203 on the same partition. So yes, 201 and 203 on the same partition. So it means my second consumer should read all these three messages. So let's go to the second consumer. So if you go to my second consumer, so second consumer read 200, 202, 204. You will never see this kind of behavior like consumer one is reading. If two consumer running in parallel, and there are two partitions, you are not going to see such scenario. Consumer one is going to read from partition 0 and partition 1 both. No, it can read from partition 0 and partition 1 if second consumer, due to network issue going down or due to some error it going down, then it is a default scenario that both the partition is going to be assigned, because this partition needs to be assigned, right? So this partition needs to be assigned. So if there is no consumer in the consumer group, because if it is down, then it is going to remove from the consumer group. Then this partition automatically assigned to the only and only one consumer. But if there are two consumer, then this partition is going to assign to this consumer, which we already see into the practical. So we are inserting so many records, and we have like uh, two partitions, some records, and we are using the random partitioner, or right. So some records publish on the partition 0, some record publish on the partition 1, and we have the two consumer running, which are part of the same group because they are sharing the same group ID. And so it means the code is same, whatever the logic we are going to implement, because I have did not change the code. If the code is like this, it has to read and it has to store into some database, then both the code is going to store into the same database. Right. So so this consumer is reading only from the partition 0, and this consumer is going to read from the partition 1. It means both are consumer running in the parallel. So if we have the two producer, and one producer is producing in partition 0 and other producer is producing in the partition 1, so we can better, instead of the one consumer, we can spin up two consumer, so that we can consume the records faster. But both the consumers should share the same group ID. Otherwise, otherwise it is we cannot call it as a consumer group, and we can't call it as called as a parallel concept, because if there are two consumer and both are sharing the different group ID, it means both are different consumer, it means both are different microservice. But here we have same microservices, a kind of a two thread application, or you can like kind of a multi-threading multi-processing application, like. So and now let's see the another scenario. So this scenario is mainly called as a control. So now another scenario is when we have the two partitions. So we have the two partition, but we have the three consumer. So let's spin up one more consumer, Python, Avro consumer, whatever. And this consumer also the part of the same consumer groups. What is going to be happen? Because we have the two partition, but this consumer is going to be do. So let's see what it is going to be do. And let me insert some record. 400, 400. 401, insert 402, insert 403. So we have inserted a couple of record. Let's me refresh it. Yeah, 401 and 403 assigned to partition 0. And let's go to the second page. 400 and 402 assigned to the partition 1. So it means now let's go to consumer 1. So consumer 1 is reading from partition 1, which is fine, 401 and 403. Consumer Second consumer is reading from another partition, 400 and 402, but third consumer is sitting idle. Third consumer is not consuming anything. Third consumer is not doing anything. So that's why this diagram is, because we have two partitions. So one partition can only and only be assigned to one consumer. All right. So this partition is going to be assigned to this consumer. What about this consumer? So it is not like that. No, no, no. We can assign this consumer to this. We can assign two partition to one. No, we have three people, but we have only two stories, two Jira stories. So one person only going to pick one story. You can consider like that. So one consumer only assigned with the one partition, second consumer another assigned partition. So this consumer is going to be sit idle. So that's why it is recommended you should spin up or you should auto scale your consumer application based upon the number of partitions. Because if you are unnecessarily going to spin up multiple application or like scale up your consumer application, you are unnecessarily wasting the resources because your consumer is not doing anything. All right. Okay, what is the another scenario? If we have three partitions but we have the two consumer, what is going to be happen? If we have three partition but we have two consumer, so what is going to happen? One partition going to the first consumer, second partition going to the another consumer. But what about the third partition? So third partition is going to assign to any of the consumer, because third partition also has to be assigned. Right? It doesn't mean that there is a no consumer, we are not going to assign this third partition. It is same case of this scenario. One partition is going to assign to the one consumer. Second partition, there is no consumer, so second partition also was assigned to the same consumer group. Right? But like if this consumer has to do this two work, if this consumer has to read from partition A and partition B, it doesn't mean it is going to read from parallel. No, this consumer is first read from partition A and then read from partition B, then from partition A, then partition B. But in this case, both are running in parallel. Uh, consumer and this consumer one and consumer two don't depend upon each other. This consumer, if find one message from here, it is going to consume. This consumer find one message at the same time, it is going to consume. So that is called of a like parallelism. Okay, so that's it. That's the end of the video, and this is very important concept, consumer group. So we have covered that in practical as well. So yeah, thank you.